Okay, today we're going to look at Unit 1, Lesson 2, solving systems of two linear equations. Okay, the purpose behind this is simply so that you will be able to solve equations whenever they come up into systems where you're trying to find out where two lines actually cross each other. Okay, so the first one that we're going to do here, or the first thing we're going to do is definitions. And so in this definition, the first one we've got is we're going to define a system of linear equations. And the ones that we will consider here consist of two linear equations whose graphs, lines, they generally intersect. Okay, and when two straight lines intersect each other, typically that's going to be at a single point. Okay, the XY point of intersection is considered the solution of the system. So when they ask you to find the solution here, what they're actually interested in is where do these two lines cross each other. And that will generally be a single point. One note that you want to know, if the system intersects at more than one point, the lines are exactly the same. Okay? If it intersects at no point, there is no solution. All right? Let's go from there. Second set of definitions and things is this. We will consider two techniques for solving such a system in this lesson. Okay, the first one is the elimination method, sometimes called the addition method, because the thing that you end up doing is adding the two equations together. Once you add them together, that gives you a solution for one of the variables. You take that and place it into the other equation, and it will give you the other variable. All right? The other method is called the substitution method. This means that you solve one of the equations for one of the variables and substitute that value into the other equation. All right, then let's go with this. Okay, so the first example, they want us to solve this system using the elimination method. Okay, so the system that they gave us is negative 2x plus 3y equals 11. And 2x plus y equals 1. Okay, so we have negative 2x plus 3y equals 11. That's the first equation. Second equation is 2x plus y equals 1. In this case, notice what's going on here. The 2x and the negative 2x are additive inverses of each other. So this means if we combine the equations, the x's go away, and that gives us a solution for y. So let's go ahead and add the two equations together. That gives us 4y equals 12. So y is equal to 3. Okay, since we found this, then we take the 3 and place it into either equation, doesn't matter which one, and solve for x. So here we go, we substitute in for y and solve for x. So we pick the 2x plus 3 equals 11. So we're going to subtract the 3 from both sides. Okay, so when we do this, this gives us 2x equals 8. So when we do the division here, x is equal to 4. Alright, so what we have here is the solution to this set of equations, or system of equations, is the point 4, 3. So if we graph these two lines, we will find that they cross at the point 4, 3. Okay? All right, then let's look at example 2. Example 2, they gave us another system, but once again they want us to use the elimination method. So what we're going to do is go ahead and look at our equations. These are our equations: 2x minus 3y equals 4, x plus 4y equals negative 9. Okay, this time notice that the x's have different coefficients and the y's have different coefficients. The easiest thing to do here is to multiply this second equation by negative 2 all the way across. So that'll give us negative 2x minus 8y is equal to positive 18. Okay, so that's what we're going to do. We're going to write the first equation down, and then we're going to multiply this one by negative 2 all the way across. So this gives us negative 2x minus 8y equals 18. Now we're ready to add, because once again these will zero each other out because they're additive inverses. Okay, So this gives us negative 11y equals 22. Solve for y, gives us y is equal to negative 2. Okay, so now we're going to take the negative 2 and place it back into one of the original equations. Make sure you go back to the original equation, not this one right here. Okay, so we're going to substitute negative 2 in for y and solve for x. So this gives us 2x minus 3 times negative 2 equals 4. Go ahead and simplify this, gives us 2x plus 6 equals 4. Subtract the 6 from both sides using the subtraction property of equality. This gives us 2x equals negative 2. Divide both sides by 2 using the division property of equality, and we have that x is equal to negative 1. Okay, so the solution to this system of equations is negative 1, negative 2. Okay, if you have questions about that, be sure you put it in the parking lot tomorrow. Okay? Alright, now the last two examples here, example 3 and example 4, we're going to use the substitution method. So this means we're going to solve one of the equations for one of the variables. In this case, we already have one that says y is equal to 3x plus 4. So this means wherever y appears in the second equation, we can substitute 3x plus 4 in for it. So we're going to do that. So this gives us x minus parentheses 3x plus 4 parentheses close equals 2. We're going to distribute the negative 1 across both parts of the parentheses here. So this gives us x minus 3x minus 4 equals 2. Combine like terms gives us negative 2x minus 4 equals 2. Now we're going to add 4 to both sides using the addition property of equality. So when we do this, this is going to give us negative 2x equals 6. Divide both sides by negative 2. Gives us that x equals negative 3. Okay? Now what we're going to do at this point, since we used this equation to solve for x, we're going to take the negative 3, put it back in the other equation for x. Okay, so we substitute negative 3 for x and solve for y. Okay, so when we put negative 3 in here, this is what we get. We get y is equal to 3 times negative 3 plus 4. Simplify this, gives us y equals negative 9 plus 4. Add those together, gives us y equals negative 5. So the solution for this system of equations is negative 3, negative 5. That's the point where the two equations will cross each other. All right? Then what we're going to do now is move on to example 4, which once again is going to use the substitution method. This time they gave us the equation x minus 3y equals 4 and 2x plus 7y equals negative 5. So this means we have to solve for either x or y, doesn't matter which. In this case, the simplest thing to do is to solve for x, since it's already by itself, and all we have to do is add the 3y to both sides. So that's what that's what I did. So this gives me x equals 3y plus 4. So this means I'm going to substitute this into this x right here in the other equation. So 2 times 3y plus 4 plus 7 times y equals negative 5. Simplify this by the distributive property, which means I take the 2 and multiply by both of these terms. So this gives me 6y plus 8 plus 7y equals negative 5. Combine the like terms, gives me 13y plus 8 equals negative 5. Subtract the 8 from both sides, gives me 13y equals negative 13. So y is equal to negative 1. Okay? Since I've substituted into this one, I'm going to take the negative 1 and put it in here so that we can solve for x. Okay? So x minus 3y, which in this case is negative 1, equals 4. So x plus 3 equals 4. Subtract the 3 from both sides using the subtraction property of equality. Gives me that x equals 1. So the solution for this system of equations is the point 1, -1. Okay, this concludes lesson 2, or unit 1, lesson 2 on systems of equations. This is a very important tool that you can have to help you with, because once you find two things are going on, you can solve to find where the common point is. Okay, second thing about this is very highly used in business in order to find things like the break-even point and where you're going to actually make profits and this type of thing, especially when there's systems of inequalities, which work very similar to what this does. Okay, talk to you in class tomorrow. Be sure you get ready so that you can come write your summary, and we will discuss any questions you have. Be prepared to put them on the parking lot. Thank you very much. See you later.